let's think about height. So height does usually follow a normal distribution. And if we wanted to explain how height corresponds to a normal distribution, we could say that height follows, with the little squiggly line, a normal distribution with mean 68 and standard deviation 4. So I've made a plot here of that distribution. Again, I'm going to put a little baseline on here. And I've converted 68 inches is 5'8". I think it's a little bit easier to think about heights in feet and inches, at least if you're American. So I converted it for my plot. So if I was thinking about, okay, this is my mean, then one standard deviation would be plus or minus 4 inches. So 5'8" plus 4 inches, what would that be? I think that's 6 foot. So this is mu plus sigma. And then 5'8" minus 4 inches, that would be mu minus sigma. I think that would be 5'4". And if I went down another standard deviation, so I subtracted another 4 inches off, this would be mu minus 2 sigma. This would be mu plus 2 sigma. So I could say from here to here, that's about 2 standard deviations. And based on the 95% rule, I'd know that about 95% of people's heights are probably between 5'0" and 6'4". 2.5% of people out in the tails, either way. So even though I think of myself as pretty short, I'm 5'2", I'm here, I'm still inside this 95%. I'm not out in the low tail. So because of the 95% rule, we kind of already know something about the percentages. So if I wanted to know what percent of students are between 5 foot and 6'4", I could say 95%. But let's say that I want to know what percent of students are between 5 foot and 5'4". So I want to know from here to here. And again, I'll stick that baseline on so it's got something to sit on. So I'm trying to figure out what is this area right there. And there's 2 ways that I could figure out what that area is. One is I could use calculus. I could do the integral from a to b of this probability density function, but that would be pretty painful. So I do not want to do that. And instead, what we're going to be using in this class is technology. And the technology that we're going to use in lecture is this website called StatKey. I don't think I've shown it to you before, but I'm going to go to it right now. It's linked on Canvas, or you could Google for it. And this is what StatKey looks like when you go to the website. This is a piece of technology. It says it's made to accompany the statistics Unlocking the Power of Data. That's our textbook by Lock, and Lock, the 5 locks. And it's got a bunch of links that we're going to use throughout the semester. But for right now, the one that we want to focus on is down in the section that says theoretical distributions. And the one that we want is the normal distribution. And I think I'm going to move my video so that you can see a little bit more of what I'm doing. Because one thing that I need to do is edit the parameters. So I'm going to X out of this again. Right now, it says mean 0, standard deviation 1. I'm going to click edit parameters, and then I can make this into a different normal distribution. So for the student heights, I would like it to be 68 as the mean with 4 as the standard deviation. And I can say, okay. And now the picture doesn't really change, but the labels that are down at the bottom do. So now this is a distribution centered at 68 with standard deviation 4. And then if I wanted to know what percent of people are shorter than 60 inches, I could use one of these checkboxes that says left tail, 2-tail, right tail. And I would like to do a left tail to see how many people are shorter than 60 inches. Let's do a left tail. Ooh, and it actually jumped to almost where I wanted it to. It jumped to 60.16, but I can change that endpoint. So let's change it to 60 and hit return. And now it says 0.23. And that's the percent of the distribution that is as extreme or more extreme. So I'm going to stick this as a screenshot into my notes. Okay, so just as a reminder, the things that you probably are going to want to do on StatKey, you're going to want to edit the parameters to change the mean and standard deviation. And then you're probably going to want to pick one of these checkboxes. And then you might need to change the endpoint. So if I want to know what percent of people are taller than 60 inches, shorter than 60 inches, what percent of people are shorter than 60 inches, and it's going to be 2.3%. That's how you can use StatKey with the normal distribution. Let's see. I have some more questions that I would like to be able to answer. I'll move my video back up. And so I'd like to know what percent of students are taller than 80 inches. So I'm going to go back over to StatKey and try and figure that out. So I can leave my mean and standard deviation the way that they are, but I want to know what percent of students are taller than 80 inches. So now instead of the left tail button, I'm going to use the right tail checkbox, and then I'm going to change that endpoint from 75 to 80 and hit enter. 0.0013, so that's not 10%, it's not 1%, it's 0.13%. So very, very few people are that tall. And I think I'll leave the other two questions here for you to do on your own. Try them out on StatKey, and then we'll talk about them in synchronous class. For the last one, you're probably going to need to change something different than the endpoint. And for the middle one, you might have to do two different things and then do a little bit of arithmetic. So what really matters here is the number of standard deviations from the mean. So let's go back to StatKey. And I'll move my video down a little bit again. So I have my parameters set at 68 and 4. And if I wanted, I could do a two-tail. And what I would see is those numbers that we were kind of approximating, plus or minus 2 standard deviations in the tails. So I've got my 60 and my 76, essentially. I'm going to take a screenshot of this for my notes. And then I could change my parameters. So let's change it, instead of 68, let's do 110. And then instead of 4, let's do 14, just because. It doesn't really change the picture. But if I do two-tail, now I get 95% in the middle. And again, I basically get that rule of thumb. So 110 plus 28 would be 138, and that's basically that top piece. So it's really about the number of standard deviations from the mean. And I'll take a screenshot of this one as well. Okay, so now we can see that we've got two different distributions. They're centered around different things. This one is centered around 68, and this one is centered around 110. But we've basically got plus 2 standard deviations and plus 2 standard deviations, and we're getting the same percentage in the tails, 2.5%. So what really matters is the number of standard deviations from the mean.